Well, good evening, everybody. My name is Brian McCullough. I'm the meeting chair for the Ottawa Centre Royal Astronomical Society. I've got this meeting and one more left as meeting chair. Working the controls here is Chris Tarrant, and we were up quite late last night assembling all the final bits for the program tonight. So it's a lot of work, and I have to say that Chris was doing the lion's share of it as per usual. So if we could have cell phones, pagers, all that stuff on silent mode, please. Run silent, run deep. All right, away we go. All right, here's the lineup for tonight. We'll give you Ottawa skies, just a heads up on what's coming up in the month. Bit of information on the nominations for the new council, because a lot of the terms are ending, and of course we have nominations for positions every year. Debra Ceravolo and Mike Moghadam will be talking about the International Year of Astronomy 2009. A couple of things on the go there. We have Jamie Westell in with us this evening with his partner Rod, with his pal Rod, and they're going to be doing a little product demo for us this evening. After the break, Richard Alexandrowich going to be talking to us about the dark side of our sun. Sounds intriguing. And Bob Hillier, when we get toward the observations segment, Bob Hillier has an interesting little segment to offer us on some of his own observations, and it will lead into the various people's observations for this evening and with our observing challenges. Okay, this is a normal setup for what we've been doing. Okay. All right. Roman Dezoba, an Ottawa Centre member who's now studying in Australia, sorry, has been sending up some images. So I've just popped these two up here this evening. So this is Sydney Observatory in Sydney, Australia. And what he says is the observatory opened in 1858 following the expansion of the signal tower then on the site. The approximate area had been used for astronomical observations by Europeans since 1788, the year of European settlement. The observatory still functions and contains a modern 40-centimeter Schmidt-Cassegrain and a 29-centimeter refractor built in 1874. And I think in that first shot we could see, I think you can see a telescope peeking out there. All right. So the 29-centimeter refractor built in 1874 is the oldest continuously used telescope in Australia. The observatory was used by Henry Chamberlain Russell to map the skies as part of an astrographic catalogue, taking some of the first stellar photographs. It took him 72 years, well, I don't know if it just took him 72 years, but the work ended in 1971 and comprised 53 volumes. It also serves as a time station, with a ball being dropped from its mast at precisely 1 p.m. Although it's a working museum, the observatory ended its research component in 1982 because of light and air pollution. So anyway, there's Sydney Observatory. I'd love to have that in my backyard. I mean, I've got a nice little observatory now, but that's what I would like. Okay. Here we go with Ottawa skies. Sorry. So here's a photograph that I took when we had the nice Venus and Moon conjunction. Actually, Jupiter was sitting up here. Okay, we'll go on. All right. November 11th and 12th. We have the Taurid meteors, and they appear to originate from the constellation of Taurus, the bull, which is why they're called Taurids. The radiant, the point from which the meteors appear to radiate, is actually a double radiant for Taurus. This is the constellation of Taurus. Here are the horns of the bull right here, and the bright star Aldebaran is right here. And now we can see the constellation of Orion. These other lines, these have to do with some of the other meteor showers, the Geminids and Orionids and various other meteor showers going on. But what they're saying is that it has a complex double radiant, and it's been suggested that there may be an increase in the number of bright fireballs this year. Okay, so yep. November 13th, just a day or two later, the moon, yes?
Sorry to interrupt, but I should say that you can see Taurids for much longer than those days.
Oh, okay. Thanks, Rolf. That's a good point, because I think you can observe them for up to a couple of weeks before and after. Is that it?
I've seen a number already.
Oh, you have. Okay.
Starting around the end of October.
Okay. And when are you observing, Rolf? Is this after midnight?
Oh, no. Taurus is up pretty much after dark.
After dark. Okay. All right. So as soon as you get a good dark sky, then you can start looking in the east southeast and have a look for some of the meteors from that. Thanks, Rolf. The moon among the Pleiades. Here's Orion again. Here's the constellation of Taurus, where we're talking about the meteor shower originating. And the Pleiades, the Seven Sisters, is just up here, also known as M45. It's number 45 in Messier's list. And the moon will be getting among there. We'll go into a bit of a close-up view here. All right. So if you're looking for photo opportunities, that's usually quite a nice one to have a look at. All right. So I believe it's a full moon that night. Few nights later, November 17th and November 18th, on those 2 evenings, you could be looking for the Leonid meteors originating from the constellation of Leo the Lion. It looks like that crouching sphinx. And that's the radiant, and you can see how the radiant travels across the 5 days. All right. Unfortunately, we've got the moon in the sky, and so it may be a bit of a washout, but always worth checking that out. All right. Okay, here we go. November 30th and December 1st. Now, the photograph that I took here, this is very similar to what you just saw a few minutes ago. So we've got Venus here with the moon, and there's Jupiter. But across the next month, Venus is racing across the sky and will catch up to Jupiter. So they'll be more or less one over the other. On November 30th, with the 2 planets, we'll say one over the other here, the moon will be here, and a day later, the moon will be there. So a couple of good photo opportunities there, but something potentially more interesting. If we go to the next one, please, Chris. All right. We're zoomed right in. There's Venus, there's Jupiter. All right. Here we are at 7 o'clock in the morning on December 1st. All right. So we're in the daytime, and we're right next to the horizon here. But if you happen to be getting a free flip in a space shuttle and we're looking down and you had a bit of a horizon, watch what the moon's going to do. That looks to me, we'll stop it at the next one. Can we go one more? Okay. That looks to me like we've got a proper occultation. And I don't know if anybody's checked the numbers on that, if that's going to be precisely that or not. But that might be something, if you had some strange way of looking at that, it might be an opportunity to look at. But even more, if we continue with this, right, so you can see the moon passing across, and it's just a slim crescent, so it's not much to look at to start with. All right, we'll go to the next.
This is the slide that shows the horizon.
Oh, okay. That line right here, that's the horizon line. This is only, what was it, like 11 degrees?
2 degrees.
Oh, 2 degrees. 2 degrees. So we'll see how things work out. Okay.
In theory, you can see the occultation as it rises above the horizon, but you'd have to have perfectly unobstructed view during the daytime to the eastern horizon with absolutely nothing in the way. So by the time it rises here just a few degrees, it's already past the occultation.
Okay. All right, we'll go to the next simulation here. All right, wider piece of sky. So there's a group of them down at the lower left. Okay, the 2 planets and the moon now covering Venus. So here we are at 11 a.m. and we'll progress across. You can see Mars and Mercury together over there. Okay, Pluto is in this area right here, but if you've had a look in the Observer's Handbook and see the finder chart for Pluto for this season, don't bother. It's in Sagittarius, it's absolutely peppered with stars, and I defy anybody to pick that out with a backyard telescope. I had a hard enough time when I found Pluto when it was in Ophiuchus, just down from, that's 20 Ophiuchi. I found it right in here. And in a sense, it was kind of busy enough even at that, but it was nothing like what this area is filled with stars right now. So, all right, so let's watch this progress across the sky. So here we are at 1 o'clock. Okay, 2 p.m., 1400 hours. Lunar challenge. How early in the day can you observe the moon? You know where it's going to be, right? You got a couple of bright planets right alongside it. That may be of assistance. So as we move across, so now we're at 4 p.m. and we'll go one more here. All right, here we're at 5 p.m. So now we're going to start being able to see some of this in the twilight. But how soon before twilight, how far back up this line can you see either the planets or the moon there? We'll call it the lunar challenge, but it's also a planetary challenge as well. All right, and we'll see for next month, either if you can bring a photograph, a sketch, or a verbal report of what you've seen. All right? Okay.
Even if you don't see it during the daytime, here we are at 6 p.m., it's now dark. And look at the tight cluster. It's no longer an occultation, but they're very close together.
And what does Sky and Tel have to say about this? Well, we're just bringing off the side. Rare and spectacular, says Sky News, but I think that's just Terrence Dickinson being over the top, right? Okay, let's go. So our past president and chair of the nominating committee, Debra Ceravolo.
Thank you, Brian. Good evening, everyone. Right, elections again. A couple of months ago, I came up here asking for people to be part of the team, be part of council, and we did pretty good. I think we filled all the positions, but hey, you know, more the merrier. We could always have an election, so anyone that still wants to be part of council has time to up till November 30th to have your name submitted. You need someone to motion and second. All you have to do is send Chris an email, and you're in, and we'll have an election. And it's been quite a few years since we had an election. It'd be kind of fun. But anyways, we got some exciting people on board. Next slide. Paul Harrison is up for president. Woohoo! And Al Scott, vice president. Chris, of course, has been here, what, about 23 years or something like that? Or?
Not quite.
Oh, that's good. That's good. We need you. A nice one thing that we were really quite concerned about was the meeting chair, because you know who can fill Brian's shoes. I don't know, Brian. The last 2 years, you've I think you raised the bar.
I was wondering how you're going to handle that. I thought
Yeah, well, you know,
we're really excited about getting a replacement in for Brian. This is good. This is good. I like that.
well, it had to be done. But Attila, wonderful that you accepted the nomination. And yeah, it's going to be a good 2 years. And if anybody else wants to take my position as national rep, that's fine too. But actually, since I am the IYA liaison, it's just as well that I stay as national rep, because I get all kinds of information from the national, bring it down to the local level, and with the museum and all the other cool things that are going on next year. So I think we got a pretty good slate going. Don't forget, next month we have the elections, the annual general meeting, and we'll try to make it as painless as possible and get on with the fun stuff. So we'll be done with that, you think? And next year, Chuck O'Dale will be the nominating committee. Okay, so I'm just going to move on to.
Oh, excuse me.
Can
What?
we stop you for a second?
Can I
Sir?
stop you?
Yeah.
Don't let me interrupt, but
Well, I have no choice, do I?
You're going to be interrupted. I'm not president. Just a couple of things I want to say. First of all, it's been almost 2 orbits around the sun that I've been your president, and I want to thank you for the honor of being your president, and thank you very much. I've been Plutoed, as they say, in the astronomy world. My term as president had sort of almost eclipsed 2 major events that happened. First of all, 2 years ago we had the GA, and this year or next year we're going to have the IYA, the International Year of Astronomy. And I just want to make the point that this lady here was primed for both of them. I'll tell you, and my personal thank you, Deborah, you did a super job, and you're going to do a super job. Now, aside from my personal thank you, would you accept, on behalf of the members,
This is the job of the nominating committee.
come on out the front.
this says 2008 Service Award presented to Debra Ceravolo
Oh my God, I'm floored.
for sustained exemplary service to the RASC Ottawa Centre.
Wow, I had no idea.
I know you did.
Thank you very much.
You're welcome, Deborah.
Wow.
So, carry on.
Thank you. That was a complete, total surprise, honest to God. Chris says, okay, nominating committee, who do you think should be up for awards this year? And I said, I have no idea, except for Chris, maybe.
Well, congratulations.
Thank you.
Now back to work, righto.
Chuck, want to come back here? You took my notes. Thank you. There you go. Okay, on to International Year of Astronomy, but first, the trailer.
For the eyes of the world,
Okay, International Year of Astronomy, pretty exciting times coming. Once in a while, but not very often, we get an opportunity to share our passion of astronomy, like a great comet. We've seen a couple of those. Meteor storms, eclipses, lunar eclipses, gives us an opportunity to get out there and to teach and to learn more and to just reach out and do some public outreach. But never before has there been an opportunity like this, and it will never come again. About almost 60 years ago, the United Nations determined that 2009 was going to be the International Year of Astronomy. Now for 60 years, well actually I should have said 60 years ago is when they started to designate years for international years and for special world issues, things that affect everyone, affect people, cultures all over the world. And International Year of Astronomy is going to be really great because personally I believe that we'll never have such a successful international year because it's a grassroots effort and there are so many astronomy groups all over the world, big groups, small groups, and it affects everyone. And astronomy is also, well, the internet itself is going to make a lot of this very, very widespread. And I'm starting to feel the momentum. I started hearing a lot about the projects coming down the pipeline. And it's actually going to get quite exciting. A couple of months ago, I was in California at a conference. It was a telescope and astronomy conference, and there was a booth there for the Pacific Astronomy Society and the International Year of Astronomy people, and I met up with this gentleman who is on the international level, and I was telling him about what the RASC is up to, and he says he is forever amazed at what he hears about the RASC, that it is such a close-knit, active group that is so huge. I mean, right across this huge country of ours in 29 centers. And the things that we do is like no other in the world. And there are a lot of astronomy groups, but there are no other like the RASC. And so we've been busy, and on the on the national level, we've been very, very busy. The Education Committee has been doing just the most incredible job. First of all, they wanted to get about 140 nations involved, and so far 130 are online and participating and getting stuff going. So that is just amazing. And of course, it's also the 400th anniversary of Galileo and his telescope and his, discoveries of the moons of Jupiter and sunspots and all that. Next slide. Okay, some of the major goals. Well, these are the international guidelines, basically, that are the reason, or the reason they put together the cornerstone projects, which I'll talk about in the next slide. I'm actually going to put on my old lady glasses now because I can read my notes. Okay, I suppose you're finished reading that now. We'll go to the next slide.
Way to go.
Get my laser pointer out here. Cornerstone projects. For one thing, somebody did a lot of logo designing. I think that's pretty cool. There's some really great ideas going on here. These are coming from the international, global level. And not every country and every group is doing what the international level is doing, but some of them are. It depends on what fits with your program. So I'm just going to read to you a little bit about what some of them are all about. For example, Portal to the Universe it seeks to provide a global one-stop portal for online astronomy content, serving as an index and a social networking site for astronomy content providers, lay people, press, educators, decision makers, and scientists. It will feature news, images, events, and videos, a comprehensive directory of observatories, facilities, and astronomical society. So it's kind of like everything in one spot on the internet, and people can go there for tons of resources. The Cosmic Diary in the middle. This one is about what it's like to be an astronomer. Professionals will blog in text and images about their life, families, friends, hobbies, and interests, as well as their work, their latest research findings, and the challenges they face. So this is going to be a really interesting place for lay people to go, and even for other scientists and astronomers to go to and find out what everybody's doing around the world, and maybe collaboration will happen from there. Down here, she is an astronomer. This is to promote gender equality in astronomy and science in general, tackling bias issues by providing a web platform where information and links about gender balance and related resources are collected. The aim of the project is to provide neutral, informative, and accessible information to female professional and amateur astronomer students, and will help increase the interest of young females to study the pursuit, a career in astronomy. Actually, Brian has a daughter in astronomy, and so do I. So, and the Galileo scope, there's another one here, the one, the little logo on the bottom. This one is to, it's for children around the world, underprivileged children, make the universe aware in third world countries and so on. There's Dark Sky Preserve, which I'm going to talk about that in a few slides later. From the Earth to the Universe, let's see if I can find my slides here. From the Earth to the Universe is a collection of some of the most spectacular astronomical images collected, put on a display in public venues such as parks, airports, art galleries, and in more than 110 countries. These are huge images that are going to be on display. Beautiful Universe magazine, which is a Sky and Telescope production. They make these once a year, but this one is dedicated for the International Year of Astronomy, and it features many of these images. And my husband, Peter Ceravolo's company, and mine are one of the few advertisers in this magazine, so they gave us a box of these. So I'm donating 5 of them for door prizes tonight, and it's really, really gorgeous. It's full of the most incredible, beautiful images, not just astro images, but images of the sky from the Earth, like clouds and rainbows and the moon, and so that's a really interesting project. Another cornerstone project is 100 Years of Astronomy, and that one is 100 hours of astronomy, round the clock, round the globe event that includes live webcasts from research observatories, public observing events, and other activities around the world. And that's going to happen between April 2nd and April 5th. And that's going to be all over the world, and we will be involved in that as well. When we get more information and more things happening, we'll let everybody know through our website, through the news, the media, astronauts, everything. See, that's one of the things that Mike and I are going to be doing. That's our job, is to gather together all these really interesting things that are happening and that are going to happen, even that we don't know about yet. We'll get it to you and have everybody participating. And Galileo scope. I want to go to the next slide for that one. The Galileo scope is one of the more visible cornerstone projects, and it, I don't know, some of you know Rick Feinberg here over in the corner here. He was the chief editor of Sky and Telescope magazine. He's one of the people that is working really, he's actually retired now doing this. He's been working really hard putting this together. They wanted to put together a telescope that children in schools can assemble, and they've already tried it out on about 20,000 kids in the US. And a couple of months ago, the National Council sent around a survey asking centers, how many do you think we could buy or want for each center? And these scopes are going to cost about $10 a piece. They're actually better than Galileo scope. So, but we're probably going to buy about 100 of them, and they will be supplemented by National as well. Now, we want to put together some kind of reason to have these, and maybe has prizes for children's contests, or maybe space art contest, or an essay contest, or things like that to do with the school. Now, we've got some time to work on this. The council's already been discussing that. So I think this would be a really good public outreach thing to do, to get into the schools and get them excited about getting a telescope and all that. And that one is, that's a national one they're going to be making millions and millions of these things. And the next slide. Now, the RASC has been extremely busy. And I have too many notes here. The Education Committee has been, working their hearts out, putting together all kinds of projects that, actually about a year ago when I was on the board pilot committee on the national level, we put out a big survey. And in that survey, we asked people, what kind of projects would you like to see for International Year of Astronomy? And the response was amazing. We had something like 60% of the population of the RASC responded to that survey, which is incredible. And I was the one that had to data mine that thing and put together all the projects that came about, and there was a lot of discussion, and basically I think 5 things were chosen that the money was going to go towards. Now this money is coming from a Walter Feebleman, who was he's passed now, he's an American physicist that donated about $30,000 to the RASC, and this is what we're using the money for. We're going to produce all kinds of materials that's going to filter down to all the centers and create these Galileo moments and public outreach events. So we'll go to the first one, Galileo moments. The next slide, Chris. Thank you. This is probably the best reason to have the International Year of Astronomy. It's to reach out to as many people as you can, and this is the way to do it. To get into the schools, to have events, not just like the RASC or local astronomy groups, but yourselves. All of you have probably done something with your telescopes, or even just not even a telescope, but maybe talk to the kids in your local school or library, or brownies, or scouts, or the beavers, or anything that you do. It doesn't have to be an RASC event. Keep track of the number of people who participate and report back to me or Mike. Mike, I'm gonna get some jobs going here for you here. I'm going to propose that Richard McDonald, are you here tonight? You're here. I'm going to propose on our website to create a counter. And after all these events, or whatever anyone is doing, is going to report back to Mike or me, or myself, or even Richard, and we're going to keep those numbers going on the counter. And Canada wants to reach 1 million or more. And I think that we can do a really good job, and we could probably be one of the best in the RASC in the country to get those numbers up and work towards that. So everything you do, go to the schools, the libraries, set up your telescope in your neighborhood and have people walking by, that sort of thing. Just report it, get those numbers out. And also the materials that are going to be coming down through the centers, you can probably get a hold of if you know you're going to have a scouting event or something like that. Pass them out. Everybody recognize Chris over here? Remember that, Chris? A few years ago. Yeah, Chris and I, we both went into our daughter's classrooms, and we did kind of a tandem thing with the telescopes and everything. It was fun. We had a great time. And so it can be displays, it can be solar observing in the daytime, it can be star parties, everything. So Mike, we're going to have to keep track of everything, keep track of people, and then report it back to the national. And when we do that, they'll give us more material. Really good. The next slide. The astronomy kit. Now this is the exciting stuff the Education Committee is putting together. A lot of things, a lot of talent here. I'm going to just mention a couple of things here. The Sidewalk Astronomer's booklet is going to have a checklist of things. It's going to have a moon map, and it's going to have something to send into the nearest RASC center. They will fill it out, review it, and you'll get a certificate back, that sort of thing. So it's things to pass out for sidewalk astronomy. The planisphere has been designed. It's really neat. It's got all kinds of great information on there. There's going to be 1,000 of those, I think, coming down to our center. Is that right, Mike?
Well, I requested 1,500 English language and 600 French language.
Okay, 1,500 plus some 600 French ones, which is, and this is all like free for us, really. We just get it out there. Mary Lou's New Telescope. This is a really great little book. It was written by Don Kelly of the New Brunswick Center. We're going to get, I think, something like 700 of those. The trading cards, there's 6 different things. There's, I think, the sun, the moon, Andromeda, a couple of others. We're going to get 1,000 of each. And so lots of ammunition to get out there and create those Galileo moments. Next slide. Dark Sky Preserve is another thing that the Canadian-wide projects. I'm not going to really go into much about this one or the next slide because I'm kind of hoping that Rob Dick, the Light Pollution Abatement Committee Chair. Rob, are you here? He's not here tonight. Okay, so I can volunteer him then. Okay, we're going to try to get him to come up here and tell you all of the wonderful things that are happening on that level. And the next slide is also related, and that is light pollution awareness, and we know how important that is. Okay, so I think I'm getting scooted off the stage here, so I'll go to the last slide. Almost the last slide. We have a couple events coming up, but lots more. These are just the kickoff events. There is a lecture happening here on December 6th with Dr. Jamie Matthews. He's going to talk about making the most of Galileo's telescope, it's called, because Jamie is the project leader of the MOST Space Telescope. And on January 7th, that's the official date now. That's been set for the official Canadian launch. And that's going to be right here in Ottawa. So we have a lot to do with that. We have a lot of, they need us to participate and help promote that. And then January 15th and 16th, that's the official international opening in Paris. And I'm sure there's going to be lots of stuff to watch about that one. So, and Mike's going to talk about more specific events that are coming down the pipeline. And the last slide. So what can we do? Well, we can do a lot. We can get out there. We can create those Galileo moments. Lots of public outreach, support the museum and all of their events. When Mike puts the call out for people to volunteer with their scopes or volunteer their time, this is your time to do it. We need lots of help. We need spread the word. There's other projects on the go that we're still talking about. We create T-shirts and pins and just get the spirit up and get it going. And the most important thing is being part of it. Me, you, all of us. Be part of, be volunteer, and make it a great one.
Yep.
Thank you.
Great. Thank you, Debra.
Well, hi, everyone. First of all, before I get started, I want to say it's a real pleasure working with Debra. She's no shortage of ideas, a very creative person, and from time to time I'll receive an email and I'll think, and I'll say to myself, I didn't think of that. What a wonderful idea. So, Debra, I really enjoy working with you. Lots of ideas, that's for sure. I wanted to take a few minutes and talk about a little bit about the Galileo lecture series. It is a very important IYA Canada program. So next slide, please. So I wanted to talk about it because I want to participate in it, and I want to tell you a little bit about the program and what I want to do. It's got a very short timeline, but I'll be responding, and I'd like to maybe solicit some help as well. So what is the Galileo Lecture Series? It is a national lecture series where the program designers have described it as 10 of Canada's most active and articulate leading researchers will be available for delivering, as they say, high-impact lectures on topics at the forefront of astrophysics. The cost of the program, or the cost of bringing the lecturers to groups, are covered by the program designers and so forth. The program has two very laudable goals. The first is they want to introduce, as they say, the excitement and reach of modern astrophysics to non-traditional audiences, and I'll talk about that because that comes up an awful lot in the description of the program. And the other is, as they say, to provide a legacy for the host site and the greater community. Now, both of these goals really interest me. The first is very much in line with our outreach program, where we reach out to new communities. That's sort of that non-traditional thing I was talking about. And the second is obviously taking advantage of this program. It's very much an opportunity for us to raise awareness of us and interest in what we are doing. So as you'll see in a moment, there are 10 prominent speakers, each with a presentation. And each of them, I think, were very well chosen. Both the speakers, as I said, are articulate and sort of leading researchers and delivering, as I said, that high-impact lectures. It looks like program designers spend quite a bit of time with choosing the right presentation so that it appeals to these non-traditional audiences. So what do we need to do here? To secure a speaker, a lecturer, there's an application process that we have to go through, and the application is there's quite a bit of detail on that. So next slide, please. The applications are ranked in part on the degree that the planned event can be, as they say, woven into that broader cultural setting. Now, that is something that I spent a lot of time thinking, inquiring about what does that mean and so forth. It's once again ties back to that non-traditional groups, which I inquired about this with some help in terms of what does that mean, and it means really reaching out to groups that might not come to these kinds of events, children, perhaps youth. Families, and as I found, even perhaps pulling into some of these events, to these lectures, things like artists and musicians. So there's a lot of you read the program description. There's a lot of that's said about how you and you are supposed to speak to this, or at least include this as part of your application. What's your plans for promoting it? Any plans for attracting sponsorship to maybe cover some of the local costs that might occur? Not so much bringing the speaker to the site, and for in terms of airfare and hotel, that's all covered. But maybe you might have some other costs that are associated with the venue or whatever. Proposed venue and expected attendance. So I'm kind of looking to the group here tonight. Maybe you have some ideas in terms of where we could be able to host something like this. My sense is that from what I've read and from what I've learned, that probably a forum like this might be too small. We might need to have a larger setting where we could attract more people. As I said on the previous slide, the application deadline is next Friday, and I'm a little behind, but I'm going to make it in time, and I'm going to get it out. So if there's anyone that's interested in participating in this from really any angle, I know I've had some interest already, and I appreciate that in terms of maybe the helping craft into the application what the promotion or the marketing angle will be. Maybe somebody has some thoughts on the venue. I really would welcome your support. There is this slide shows this slide and the next slide show the various lectures and their programs and so forth. But what I wanted to do is just speak to the two of the programs. The first one, which was on the past slide, which was called the Cosmic Dawn and Monster Telescopes. And what I wanted to do is just read quickly the abstract that is on the web for Cosmic Dawn and Monster Telescopes. That presentation, and it'll give you an idea of just how much thought they've put into designing these lectures, and I can see that it will attract audiences. So the first one reads, the Cosmic Dawn and Monster Telescopes reads, the universe, soon after the Big Bang, was a dark, bleak place, devoid of galaxies, stars, planets, and even the basic elements of life. This cosmic dark age ended with first light, the illumination produced by the first generation of stars and galaxies. We know almost nothing of these early objects except that they somehow started the cycle of cosmic birth, death, and rebirth in a chain reaction that ultimately resulted in the complex universe seen around us today. In this lecture, I will show you the lecture. After decades of searching, astronomers are now on the verge of finally observing the sources of first light with the latest generation of monster telescopes both on Earth and in space. So that kind of is very engaging. I think with the proper promotion that could attract a wide audience. The other one I wanted to read to you really briefly here is, and again you can go onto the web and I guess Google Galileo lecture series to see the descriptions of them all. Is the abstract for the galaxies like grains of sand. And this one here reads, early in the 20th century, cosmology underwent a stunning revolution with the realization that galaxies were island universes of their own set in the expanding fabric of space and time. We can now peer through the universe almost all the way back to the Big Bang. Everywhere we look, we see myriads of galaxies of all shapes and forms like grains of sand on the shore of our cosmic ocean. Many mysteries surround these majestic structures, some as massive as 1,000 billion of our suns. How do they form and evolve? What is the dark matter they contain? What is the fate of our Milky Way? Astronomers are now deploying an impressive array of giant telescopes and powerful supercomputers in the hopes of answering these basic questions. this talk is the story of our ongoing quest. So very much engaging here. Of the 10 lectures, I would say that 8 out of 10 are very much of interest to me. Perhaps they are as well to you. The way this works here is we pick our top 3 of interest to us, and it gets the committee the program committee looks at all the applications, and depending on the strength of the application, you're either awarded the lecture or not. We are fortunate to have someone in our group who does know one of the program coordinators, Brian Ventrudo. Brian, are you here tonight? Okay, well, Brian has been really helpful, and he's been able to have a correspondence with the program designers and given I almost think some inside information in a way of what it is that they're looking for in the application. So I think that's really going to help me quite a bit here. So it's the application. Going through it, and I have till next Friday to get it done, and I want to do it. I think we can, with a little bit of thought, and we can make it happen. Okay. All right, so something else I wanted to chat about, which is just give you a little bit of an update on RASC outreach activities in our center here. Just give you a look ahead. But before I get started on this, I was hoping actually at this time to start off the talk by saying a few things about the successful Star Party at Saunders Farm. But as you know, we had 2 strikeouts, and first we had clouds that I was watching it that afternoon, and half the sky was sunny and the other half was cloudy, and I was just crossing my fingers, and unfortunately the clouds prevailed. But I went out to the event, as you may have seen in my emails, and anyhow, just in the anticipation that maybe some people might have gone out there, and I didn't want to strand them. And lo and behold, I found that the Saunders had put up massive floodlights, and they did that the day before, the Thursday before the. So that was a real shock for me, and in a way, maybe that was a good thing that it was canceled, because that really would have ruined the event if we all had gone there, set up our telescopes, and boom, the lights came on. They put the lights up because of I think a car accident that occurred the weekend before, and then the second when I planned the event, when I rescheduled for the second time, clouds came in again, and then the next week after that, you may remember that, of course, the snowstorm. So I got to do something different to make this happen next time. But I did learn from that, and you know what? I'm still as motivated to do this again. So patience with me, and sorry about that. We'll make it happen again in the future. Okay. So some of the things that are happening at the Science and Technology Museum. Debra talked about the lecture that is coming up with Jamie Matthews. So I won't talk much about that, other than just saying that the museum has actually asked for us to help have a little star party right after the event there. They're looking for 4 to 6 telescopes and support for the observatory as well. So stay tuned for that. If anyone is interested, and I really hope there are some people who are interested. Tim, Tim Cole, they ask for you a lot. Your name comes up a lot in the emails and so forth. But we have to recognize as well that we're here because of the museum allowing us to use the space. So we need to do our part. December 21, it's a winter solstice event. I'll as I learn more about this event, I'll send out emails and so forth. But it's similar to events that we've had in the past year and past years and so forth. Debra talked as well about the launch, IYA, and if you go even further out on the horizon, and once again the astronomy day way into May. Okay, so. Some of the other things that are planning, I sort of keep my eye on the IYA and the RASC national website, just to see what other groups are doing in terms of IYA activities, in terms of just general outreach and so forth, and a couple of things that popped up which really have captured my interest, and Debra and me are sort of in synchrony on this one here because it appealed to both of us. What we've noticed, what other groups have done, and I believe there's a group in Vancouver Island group, and there's a group I believe in Chicago, and another group in California, and another group in the Toronto area, have taken advantage of local orchestras that have combined sort of a musical score, and quite often it's a musical score by this fellow, this composer Gustav Holst, and an astronomy event. So in what we've seen is what I've seen from what other groups are doing, or just what I read from what other groups are doing, is they'll have an orchestra playing a musical score of Gustav Holst of the Planets, and at the same time they'll have projected onto a giant screen a series of slides of various astronomy images and so forth. And coupled with that, I've seen things like as well. I've read about things as where after an event like this, you'll see telescopes set up outside and for people to look through telescopes and so forth. So it's a funny thing, when you think about this, because you may say, well, why are we doing something like this? But isn't this the essence of outreach? I mean, it's just to reach beyond our own sort of group and into other communities. So I think there's an opportunity here, and I think something like this could snowball. So there's two things that struck me in discussions I've had with Debra and others, is possibly engaging the NAC orchestra to, and obviously this is going to would take a long time for planning on their part to do something like that, where they would have some sort of an astronomical themed music. Maybe it's Gustav Holst of the Planets. And we would offer our own support. Debra came up with a neat idea, which possibly having a professional actor dressed as Galileo, maybe delivering some sort of talk throughout the evening. Another thing that I noticed, and I think there's a group in Toronto that's doing this, is they're working with a group called Tafel Music. Some of you may know about this group here. They're an orchestral group that they do a lot of touring, and they've come up with something they call the Galileo Project, Music of the Spheres, and there's a bit of a description of it in the bottom there. But I've been learning a little bit about this, and I've learned that they're going to actually be coming to Ottawa in is it March? March, and I'm in the process of just starting to talk to them about how can we maybe partner with them. So what I was just delivering something like I described a second ago with the NAC orchestra. So if they already have something underway, we might be able to either sort of get involved with that, or not. Maybe they might just say we've already done it and so forth. But I really want to see how far we can get with that, because if they're coming, if they've already got a musical score, there's no development required. It could be pretty exciting, I think. So, and just a little bit. I mean, one of the things that it looks like what they've done here is the Galileo Project. I've read that the way the evening progresses with the Galileo Project with Tafel Music is it says here, told through the eyes of Halley's Comet, this interactive performance explains the workings of our solar system and explores the exciting developments that the comet discovers on its visits to Earth, including the makings of the first violins for popular music, the first oboes and bassoons playing for the Sun King Louis XIV, and so forth. So you can see this merge of astronomy and music, which I think is pretty creative. So stay tuned. I'm pursuing that as well. I think that's it. Oh yes, and I guess I don't know if it'll play, but can you click on the little speaker there? I don't know if you can hear it, but this is the Jupiter score, and just picture in your head a series of slides, showing astronomical scenes, and so forth. Yeah, that's it.
All right. Thank you, Mike. Thanks a lot, Mike. Oh, good. Good job. You gonna finish, Mike, then?
I think we might do that.
Okay.
Oh, I'm really humbled by you guys. I mean, I've never been into anything like this, and it's just like nice to see a whole bunch of conscious people. And I'm just trying to sell hats.
Well, they don't know that yet.
Well, you're gonna find out. So I originally started this business and to sell to law enforcement and industrial people, and these are hats with LEDs on them. And a friend of mine said, he was up in the Gatineau and he saw all these guys with red flashlights. It was like fireflies from, all going up there. And he said that maybe you should talk to astronomers. So that's what I'm doing, because I've got lots and lots of positive response about this. It's a 4 LED hat. And I just wanted to, I wanted to make some crude jokes, but I'm just going to make a little one here. I read this in Harper's. Astronomers noticed that the A-Bell 520 galaxy cluster has a massive dark core, which is presumably dark matter, though it is separated from any bright galaxies, which tends to upset established theories about the mysterious invisible cosmic substance. That sounds like my head. So you put it on, and this is what goes on. You can set up your telescope at night without losing your night vision. It's got a safety switch, so you just turn on the brim, there's a switch. You go click, and you get your red LED lights. And when and then you just, as you set up your telescope or your camera, you just flip the hat back, get it out of your way, do your stuff, and when you're finished.
Can I read by that? You can read your observing notes from this. This is great.
And so, you know, at the end of when you're going down the mountain, going down King Mountain or wherever you are, you can flip on the other the white LEDs, and you just go 1, 2, 3, and you got the full.
Oh, it's the same cap.
Yeah, it's all there, and you can have all 4 of them on at the same time. So I figure they're really useful for you guys that are conscious. Yeah. Rod is actually works for CHEO. He's actually a microscopic guy, and he looks at living things. You guys just look at things that are dying, but well, some of them are.
No, we look at heavenly bodies. We look at heavenly bodies, right?
Heavenly bodies, celestial bodies, and yeah, I had to sort of congratulate. I just read this article about this Alicia Soderberg discovering that supernova. I'm looking for a name for my hat too. So anybody got a good name for my hat?
Anybody have any ideas for a name for a hat? Flash hat.
Yeah, but just I wanted something sort of universal. Maybe that's it.
Wait, what's the other one? Red cap.
Yeah.
Isn't that? Wait a minute. Isn't that a? Oh, sounds like a beer.
An old style beer.
That's right, yes.
Is there any questions at all? Do you want to know anything about it?
What if you want to turn left? Can you signal?
Yeah, the high beams or low beams. Yeah.
Powered by brainwaves or batteries?
Just they're powered by CR2032 batteries, which they last. You wouldn't even notice until about 30 hours. Yeah,
Nightcap.
That has been suggested. It's it seems to sort of indicate some sort of alcohol consumption. But, so I'm giving you one of these hats here for the draw.
Okay. We got
And-
some. But
Can you adjust the LED intensity, a little bit intensity?
What I've found out, I've been experimenting with this over the last 6 months, and you can, but I can you can take there's 4 batteries in them on either side of the head. You can use these in the winter. The batteries are good to -30, so they're in your head. They're warm. The LEDs like cold, and you can put a toque over your hat, and you can take a battery out and just put a conductor in. It'll
Or a dead battery?
then, of course, the other battery,
No, you can put it one dead one,
you could,
right?
no, that's not a good idea. No, you put just any conductor, like a dime or something, or whatever, a paper clip, and that'll, it'll, if you look at a camera stopwise, the red LEDs go down 1 stop, just by putting a conductor in. The white LEDs go down 3 stops by just putting a conductor in. Now, if you wanted to go down even further, you could use a resistor, but that's easily done.
fantastic. Or old batteries, yeah.
Well, you're gonna kill the other battery with if you use. You never use old batteries with new batteries. Don't you notice that? Come on, guys. Never. And also you can just if you only use it occasionally, you can put the batteries in the freezer. It'll last forever. Is that enough?
Any other questions at all, Sylvie? Oh, what's the price?
Oh, tonight only. I've got.
Order in the next 5 minutes.
Yeah. In the next 5 minutes, yeah, they're $40, and you can get them at the local. You can get it in Le Maison, Le Maison d'Astronomie in Montreal, or you get them from Kent at Focus. They both got them in stock. But tonight, you get them for $40 cash. Plus, someone gets to win one.
He's putting one in he's donating one for the door prize tonight.
Yeah.
Okay, so thank you very
Thank
much.
you.
Jamie, thank you very much.
Richard, is that you at night?
That's Richard at night, yes.
Well, that idea came to me at 2 o'clock in the morning, coming home from Montreal from work, and on a lonely country road when there was nothing around. So these are the times when the greatest ideas come to mind. Well, I'm going to be talking about the sun, obviously, about things that are happening with the sun, or rather, thereof lack of happening with the sun. It's been acting strangely, and I don't think there's any need to panic. But anyway, some of the news items have been rather a little sensationalist, but I'll go into that shortly. But first, we're going to give you an introduction, Astronomy 101, about the sun and how it works, its internal dynamo. It is the most conspicuous object in the sky, and it is our primary source of heat, light, and energy. And without it, as you know, we cannot exist, and it is our source of moral support, our inspiration. It is our anchor to our well-being on our daily basis. Having a sky without a sun would plunge our planet into a frozen wasteland covered in eternal darkness. And as a matter of fact, at times we take it for granted that it's out there. Next, please. Our ancestors waited for its appearance in the east so it can provide warmth and light to their crops. And during the winter months, the ancients even feared the sun would disappear below the horizon as it sank ever lower and perhaps never to return. To the Greeks, it was known as Helios. In Latin, it was called Old Sol. Today, it is an object of intense scrutiny that is worshipped by the modern-day astronomer. Next, please. It contains about 99% of all mass in our solar system, and our nearest star has found its way into novels, poetry, and even into music. It is an enormous sphere composed mainly of hydrogen and helium, two of the lightest gases in the universe, which converts 5 million tons of matter into energy each second. Next, please. And just to briefly go on some brief quick facts, its mass, of course, 333,000 Earths could go on one end of the scale as opposed to the sun to equal. Surface density there, 1/6,000th that of the atmosphere. The core density, very, very dense, 10 times that of lead. And of course, like I said, hydrogen, 94, helium, and other heavy elements such as phosphorus, calcium, oxygen, and the list goes on and on. Next, please. Just to recapitulate quickly, there is the core, which is about a quarter of the size of the sun, or around 15 million degrees Kelvin. That's the internal temperature. The temperatures are so hot that the pressure and the temperatures can cause the hydrogen nuclei to fuse hydrogen into helium, and this therefore giving large quantities of heat and energy. The next area, we might as well go on to the next slide as well. This is a little bit easier to understand. There's a convection core, and like I said, then there's the radiative zone, which makes about 25 to 70% of the distance to the surface of the sun, or the photosphere. It's about 7 million degrees Kelvin and transparent, which means that energy and light can travel from atom to atom without actually being absorbed. It is very dense, and it takes about 1 million years for one photon of light to travel from that zone to the surface of the sun. The convective zone, which is marked just below the granulation area, transfers the heat from the deeper zones, and it transfers the heat to the outer areas, similar like that of boiling water. And then the photosphere, or the surface we see, the one we can see through our amateur telescopes, is about 100 kilometers thick at 6,000 Kelvin. The sunspots are areas of magnetic fields that are cooler and only 3,000 degrees Kelvin, but still quite hot. The chromosphere is the immediate layer above the photosphere, which is a thin, hot layer above the photosphere, 20,000 Kelvin. And the prominences are where you can see prominences in this region. The corona, finally, is the thin, tenuous outer layer at 1 million Kelvin. Maybe go back to the other slide to show the corona and the chromosphere, which is just above the photosphere. The bright white spots there are flares. Okay, so we'll jump to the next one. Okay. Now, our sun is just an average run-of-the-mill G2 5 star located in the suburbs of our Milky Way, and that's about 2/3 of the way from the galactic core. It is only but one star in a total galactic population of several billion. Now, studying stellar dynamics is in some ways similar to classifying human beings here on Earth, each having its own traits, including personality and character. Next, please. A solar physicist is like a geneticist, teasing out the world of the incredibly small and trying to find out just what actually makes it tick. So solar astronomers have gathered a great deal of valuable data from our star from instruments on Earth as well as in space. However, there are aspects of solar dynamics that still remain poorly understood. And one of these include the cyclical variations regarding solar activity and its underlying cause. Next, please. When we talk about solar activity, we include the changing patterns of sunspots. These are actually concentrated areas of flux concentrations where the transfer of energy is impeded from deep within the solar dynamo. That's the Earth compared to a typical sunspot. Some of them are even much larger than that. And, okay, we'll go to the next one. As well as a variable emission of soft X-rays. This is almost a 3D image, you can say, of the roiling atmosphere of the sun, and you can see the magnetic lines in the just near the sunspots here. These are the areas where the magnetism grabs the substances in the solar atmosphere, and these are the granulations. The light areas where the temperature rises, where the air rises, and the dark areas where the matter starts to sink below and it starts the whole process again. So there are also emission of soft X-rays, spectral lines of calcium-2 and magnesium-2 atoms, as well as solar flares, which are high-energy electromagnetic waves spewed forth from the surface of the sun. Next, please. This is the sun and different amounts of radiation that comes from the surface. On occasion, our star will exhibit temper tantrums and causing some inconveniences here on Earth. When solar activity increases, consequently, its luminosity increases as well, but only in extremely small amounts. You would need special instruments to measure the increases. As a matter of fact, instruments were only able to increase a very minute change in luminosity since the time they were building the pyramids. Next, please. A simplified diagram of the way the magnetic field works on the sun. The sun's activity is fueled by an underlying force. It is the distribution of magnetic flux or movement in the photosphere, chromosphere, and its searing corona. Of course, there's the sunspot pair, very simplified, and they're usually plus and minus polarities, and of course, at the beginning of another sunspot cycle, the polarities reverse. Next, please. This is, I think, taken from TRACE. You can see the coronal loops going high into the solar atmosphere. Our Earth would probably be about the size of the star, whatever this apparition is right here. So you can see it's a huge beast.
Is this a photo or an animation?
That's a photo, actually, from TRACE. Yeah. There are some very good photographs on the internet. And you can see it looks like a roiling ocean, a very seething cauldron. And these are the magnetic lines going over. And of course, it traps the plasma traps the ions in the atmosphere. Now, what happens is the magnetic fields are dragged deep into the sun's interior and combined with varying rotational speeds, or differential rotation, they call it, at different latitudes. There are electrical currents that are produced, which in turn create these magnetic fields. Next, please. Now, the sun is not one complete body that rotates like the Earth or the planets. It has varying rotation speeds at different latitudes, the equator being the fastest. So by the different amounts of rotation as you go from different parts of the latitude, of course, it takes slower near the poles. It creates this shear effect. It's sort of like a wind shear effect that you get in an aircraft, and this is what creates the electrical currents. Next, please. Now here's another image, again, a little bit more spectacularly. These are the flares, and these are the prominences going several 100,000 kilometers into the atmosphere. Sometimes what happens when a prominence goes up into the air, the sun's tremendous gravity pulls it back down again, and so it's not able to go project outward toward the Earth. So in a case like that, we're saved. Next, please. So what happens is that fields form twisted magnetic flux ropes, which house enormous quantities of stored energy. And when the sections of these flux ropes charge through the sun's surface, it is then that we begin to see the signs of a solar activity. That's a solar flare coming out there. Loops or filaments are observed when magnetic fields trap and confine ionized gas found in the solar atmosphere. So that's what happens in the loops that you've seen in the previous images. There's just material that's being dragged in from the magnetically charged arcs. Now, occasionally the sun's magnetic flux will perform a type of rearranging act, and this will lead to distortion and stressing of any magnetic structure on the photosphere. Next, please. Now, what will happen is that all magnetic energy then becomes stored, and sooner or later, like the typical analogy of the elastic band, this energy must be released, so it snaps. And this is when the solar activity starts to happen. And the show begins in the form of solar flares and CMEs, or coronal mass ejections. Solar flares are, like I said, giant magnetic explosions originating from the photosphere. Next, please. Oh, okay, we'll go back to the other one there. We're a little bit ahead here. And CMEs, as here, this is an illustration with Earth in comparison, are clouds of ionized gas that weigh billions of tons that race toward our planet. They can, speeds can reach as high as 2,500 kilometers per second. And they can reach us in as little as 17 hours. You got to remember that traveling to the sun in a 747 will take you 17 years. This takes just 17 hours. Now, both flares and CMEs can trigger the northern lights. That's the next one. And this is a photo taken from the ISS. This happens when our magnetic field separates the electrons and protons thrown off from the surface of the sun. The process generates an electric field providing the power for the aurorae. Now, the same phenomena, radiation that is hurled off the sun's surface and coronal regions, can have dire consequences as well for our planet. Next, please. This is just an idea to show you some of the satellites in orbit around the Earth, some of the space junk we have. And that's only the closest part, but of course, there are parts that are, as Mike would say, there are other areas further out that are not in this photograph. So when an activity on the sun happens, satellite circuitry can be damaged, compromising their effectiveness regarding their day-to-day human activity, including navigation and oil drilling operations. Radio communications can be affected as well if you are a ham operator. Next, please. And of course, if high-speed particles begin to act with oxygen and nitrogen atoms, showers of high-speed neutrons could ultimately crash computer systems. And one thing I did miss out here is the currents flowing at the top fringes of our atmosphere can induce ground currents in long conductors, such as these power grids here, and damaging transformers and resulting in massive blackouts. I'll get to that shortly. A solar event can also damage anywhere from 5 to 10% of our ozone layer, increasing the risks of skin cancer. Bright auroral displays would also render wildlife, which I didn't know, in a state of confusion. Nocturnal rhythms would then become chaotic, so the animals won't know whether it's a true solar day or whether it's an auroral solar day. Also of note is that if the magnetic field of a CME is oriented north, it would minimize its interaction with our magnetic field. Next, please. So cycle number 23, it has now for the most part come to a close. Since 1996, it has produced over 21,000 flares and created 13,000 coronal mass ejections. Number 23 was well behaved, with the exception of a record-breaking flare on November 4th, 2003. Next, please. But once every 400 or 500 years, our star will erupt in spectacular fashion. The classic example is the superstorm of 1859. It was so unique and powerful that it was placed in a class by itself. It was so intense that aurorae were seen as far south as Athens, Greece. Now, the cloud that was launched by the sun traveled across the entire inner solar system in 17 hours at the speed of 8 million kilometers per hour. This time, the magnetic field was pointing south, thus enhancing its impact upon the Earth. Back then, we were not as savvy about aurorae as we are today. Spectators thought that those dancing lights in the sky, the aurorae, were caused by fires in distant cities or even ghosts celebrating over a celestial battle. The storm's shifting magnetic field generated underground currents so powerful that telegraph offices on both sides of the Atlantic were set ablaze. You have to remember, this is the pre-Civil War era. Unlike earthquakes, superstorms are highly unpredictable. Solar forecasters are even daring a long-shot guess, now this is just a guess, so don't panic, that one may be hiding its ugly face in the upcoming cycle number 24. Like I said earlier, things that are kept in energy that is kept contained will snap like an elastic band, so maybe it'll be the calm before the storm. Well, if one should rain upon us, that is the solar storm, it would be between 2010 and 2012 near solar maximum. The best months, get your papers and pencils ready, March or September during the equinoxes when we are most vulnerable to the attacks. Next, please. Now, the warning signs for observers like us, we would notice a large distended group of sunspots on the solar disk, similar to this one. This would tell us that the magnetic flux on the sun would be highly unstable. A superstorm of sufficient magnitude would most likely disable all sensor equipment in orbit, in space, notably on the sunward side. X-rays and other high-speed particles would wreak havoc upon our satellites, disrupting communications and other services that we have come to rely on. GPS and satellite technology, satellite TVs would go off, so there you go. In several hours, revenues and resources would stand to lose billions of dollars. Next, please. Remember the massive blackout that plunged Quebec into darkness of March of 1989. It lasted 12 hours, but not before causing billions of dollars in damages. But the funny part about it is that it wasn't even mentioned in any major American newspaper. So it just goes to show how much they know about Canada still. According to US statistics, the power industry and satellite commerce generates about $500 billion annually in revenues. Could we afford to stand by and wait for the next superstorm to compromise today's technology? Now, what about the sun's current sluggishness? This is the question we've all been wondering for the answer. It's been a hot issue within the scientific community, but lo and behold, some sunspots are actually beginning to poke through the photosphere. The sun is now passing its low point in the 11-year cycle. It is this time period that separates one solar maximum from another. And there have been some published reports that the minimum is lasting longer than it should. However, this is not true. This ongoing lull in sunspot number is well within historic norms for the solar cycle. Some observers are a little baffled regarding the ongoing minimum now going into its third year. We can say that our sun is now idling, perhaps bracing itself for action in the months ahead. One must realize how long a solar minimum can last when you think about it historically. During the early 1900s, there were quiet periods with durations that lasted nearly twice as long. Humanity has been taking records of the sun since the mid-1700s, and we all know that our nearest star has been around quite a lot longer, 4.6 billion years to say the least. We can only imagine the colorful story our sun could tell if we were around way back then. And the bottom line is that the 11-year cycle need not follow our carbon copy rhythmic pattern. Next, please. What about the time when some of us thought that the solar cycle had broken down completely? It was the longest minimum on record. The so-called Maunder minimum lasted an incredible 70 years, from 1645 to 1715, which is right here. And these red spikes here are the normal patterns of sunspot activity. So as you can see, there's I think this one here is the Dalton minimum, and there's another one called the Sporer minimum as well. But the Maunder minimum was the king of all. Sunspots were rarely observed. Next, please. This period of solar slumber, the Maunder minimum, coincided with the mini ice age. Thinking back of the winter we had last year makes me think. Those in the northern hemisphere had experienced long and bitter winters. But as curiously as it came to end, the normal cycle had resurrected itself early in the 18th century and has since carried on with the familiar 11-year pattern. Next, please. The quiet of 2008 most likely is not the second coming of the Maunder minimum. Some of us have already known that a few tiny sunspots are beginning to poke through the photosphere. Now the cycle is progressing normally. Cycle number 24 has been long and quiet the first 7 months, averaging a sunspot number of only 3. In fact, there was only 1 sunspot number in August. Some say nothing, depending on which source you take it from. The rapid drop of the past year has defied predictions and caught most astronomers by surprise. Now, to end it all, this will only take about a minute here, there's a little story I would like to share with you. In 2005, 2 astronomers working at the National Solar Observatory in Tucson, Arizona, had recorded minute spectroscopic and magnetic changes within the sun. So by extrapolating forward, they predicted that within 10 years, now you have to remember it was very active back then, they predicted the sunspots would vanish completely. Consequences of all this had their peers laughing at that time because they lacked additional observations to back up their forecasts. The paper they were working on, unfortunately, was rejected because simply it was too controversial. The paper's lead author, William Livingston, had acknowledged that the refusal may have been justified back then, but recent data fits his theory well. So they were, in fact, correct. And that's it.
This is the latest diagram of the Milky Way galaxy. Thank you, Chris. You have the pointer there still? Yes, I do. Ah. Thank you. And if you have a look at this, it has it available on Sky and Telescope's website. But look at older images and diagrams of the Milky Way to see how it's described. And what they're showing now is that there are primarily just 2 prominent arms to the Milky Way galaxy, and a couple of little spurs here, the Orion spur. They're talking about some of the smaller arms inside, but it's nothing the way that they've shown the galaxy in illustration before, certainly with a lot more well-defined spiral arms coming out. So this is how the science has developed in the depiction of the Milky Way galaxy. All right, okay, off we go. First light experiences. Bob Hillier.
Next slide. About 10 years ago, I started getting involved in astrophotography, and I first started with a black and white quick cam camera, and it had its wonderful characteristics that frustrated me to no end. At that time, I had heard about a Genesis 16 camera kit that was available on the internet. So I bought the camera and built it, put it together. It was like an S-Big ST7, same CCD. And I was very proud of it. I was pleased with the images I was getting. The first light image I took was of M27, and we can see here, it's not the best type of image, but I was proud, I was pleased. I had some significant challenges here with focusing, and probably the most significant issue was with respect to noise. I had tremendous noise in this image. But I liked my camera, and I did lots of fun stuff with it, and I learned a tremendous amount with it. Next slide, please. After a number of years, though, I grew tired of it, and I purchased a DSLR, a Canon 20D, and I started to take some images with that. The first light image with the 20D just happened to be an M27 as well. And it's significantly better than what I was getting with the G16 and a much better field of view. I dealt with and resolved my tracking issues, so this was 10 by 3 minute exposures, and my aperture was a lot bigger with a C11. Next slide, please.
Is that a modified 20D?
That's a modified 20D. I had played with that for quite a while and grew increasingly frustrated with some of the characteristics of using a DSLR on the telescope instead of using a camera that's specific for astronomy. And I had decided that I was going to buy an ST4000. At that time, I had been spending a lot of time at a friend's place out near Maberley, Ontario, with his ST2000, and it was a great little camera. And when I decided to buy the ST4000, the couple days before that camera arrived, I went out to his place, and we shot this image of M27. And this was 10 by 5 minute exposures on a CG11. And this was just before Thanksgiving weekend. Next slide. When I got my ST4000 in Canada, I went after M27, and this is my first light image. This was 9 by 10 minute exposures, and I was quite pleased with it. But I wanted to understand the difference between my light polluted skies and his nice clear dark skies, so I started to compare the images and just look at the different characteristics. Next slide. And what I found was, in his slide picture, there's a star there, and in mine, it was missing. This is the first time I've ever found something missing in one of my pictures. So I was really excited. I thought, oh, gee, what's this? Of course, I first thought it might have been a variable star or something like that, and I started to do some research about this to try to figure out what was going on. What I did do was go back through my old notes, next slide, and I started to look at some of my older pictures. So I went back to my Genesis picture, and sure enough, the image is there, or the star is in that image, and I went back to the 20D picture, and the star is not there. So this was deeply concerning to me and a little bit frustrating. So I figured it might be a variable star. So I went hunting for variable stars. And in M27, there is a variable star that is right here in the Canon 20D. There is a variable star that was discovered in 1999 by a German astronomer. And I thought, well, gee, maybe this thing is a variable star as well. But I did some research, and I could find no information in the general catalog of variable stars or any of the other reference sources that I had gone to. So then I started to look for other possible explanations of why my first light experience with my ST4000, this is supposed to be the best camera for me, why it was so different from the ST2000. Next slide. And I was pondering why there are so many red light differences. And if I had the two images side by side here, when you see them side by side, you start to see that the ST2000 is much more red sensitive. So that caused me to think, well, maybe there's something to do with the red filter media used in the Hillier camera. Next slide. And I went off and I found the quantum efficiency curves. And sure enough, for the ST4000, we can see it's got a very sharp drop off here at about 650 nanometers. For the DSLR, it's also got a very sharp drop-off, 650 nanometers. So both of those cameras have a very sharp drop-off, whereas the ST2000 continues to have a very strong response at that level. So I concluded that it might be because of these red curves. And when I took did a bit more research, I found out that the O2 light, or stars that have a lot of O2 light in the heavy red zone, they would be in this particular range. Next slide. So after a lot of research, I concluded that it must be because of this particular star in this nebula that has a much stronger infrared response than my camera is able to detect. For some reason, I couldn't find information on this particular star in any of the star catalogs, and I recall hearing briefly somewhere else, perhaps here, that stars in nebulas aren't mapped as well as stars that are outside of the nebulas. But for me, it was an exciting time of finding something in one image that wasn't in another, and it led me down a lot of different research paths and looking at a lot of different pictures. It's important to keep looking. It's important to go back and look at your old notes, because your old notes may have information in there that you recorded that you didn't realize you put in there until you start comparing it to something else. And probably the most significant thing for me was that things change when you least expect it. Thank you very much. Next slide. Next slide.
All right. Thank you, Bob. That was great. And just a note on that, when Bob was putting the presentation together, and he said, well, he detected possibly a variable star, and doing all the right things, going back and looking at other images. I know that he asked me about that. I contacted Doug George, and we were directing Bob onto maybe some other places he could go to look to find out what's what on there. And Doug was the one who raised the idea of possibly different filtration on the various images might have had something to do with that. So good team effort, and I thought it was a very interesting observing experience to have all told. I've got your observing token here, by the way, Bob. I'll pop down in just a second. All right, let's rock on. All right, and into the observations proper. Away we go. Gary.
Thank you, Brian. Well, nights like this don't come too often, especially from Barhaven. Turbulence is always not an asset when you're trying to do some brain imagery, planetary or the moon. It was the night of October 18th into the morning of the 19th. I decided to photograph the moon. I opened up the observatory around 9 p.m. and waited to start around 1 o'clock in the morning when the moon was nicely over the roofs. And I didn't close until 5:40 a.m. The imagery I was taking, the video, with the TU cam was just amazing. It's almost like Mike Worth's shots, but he'll never come close to his kind of shots. But for me to get imagery this good, it's pretty well once a year. So this is and this is Berg, Greater Berg, and Theophilus. Is that how you pronounce it?
Yeah.
Theophilus. Just the names are enough to learn. Forget about what the crater looks like. So again, I used the 12-inch Meade LX200 with the TU cam. I was working at the focal length of f20, which I don't get to use too often. I used Registax 4 to stack the images, and Photoshop elements to refine it, but still pretty well. It was a pretty good night. And just while at the podium for the astrocasting, I've been broadcasting, well, with the weather changing, I only pretty well do it on Friday and Saturday nights. But I do update my website, wondersofastronomy.com. I do put a line in the bottom, the next dates that I plan to broadcast, hopefully next Friday or Saturday, or maybe if it's even clearer during the week, do the move for maybe an hour or so. So keep checking wondersofastronomy.com. Log in, it's through Yahoo Live. You can do a chat, and hope to see you on board. Thank you.
No, neither were we. We just we found it and we took it on a chance here.
Okay.
Is this your shot?
Yes, it is.
All right, come on up to the mic.
Okay.
Never adaptable here.
Yes, I think that was August or September maybe.
I think so, yeah.
And it was like a crescent moon and twilight, and that's the roof of my observatory. And that actually, Mercury was really blazing that night, as I tried seeing it for the next couple of nights, and it was very much harder to see. But it's not very often that you get to see Mercury that bright in the
Beautiful
evening
shot.
sky.
All right, excellent. Thank you. I'll get your token out here in just 1 second. I'll just come down and see you in just a second. I was wondering for a second on that shot because I saw the open doors on the open shutters on the observatory, and I thought that looks suspiciously like my shutters on my observatory. But anyway, I think we're good to go there. Attila.
Okay, I've probably been doing too many observing challenges, so I think Brian wrote me into giving this observing report as punishment. In case I went observing last Saturday at this observatory. This observatory was built by Mike Wirtz. It's a 25 by 30 foot observatory he built for his 25-inch obsession. Now that Mike has retired to Mexico, it now houses my 25-inch obsession. And one thing to know about this observatory, do I have an advance button on this? Or?
No.
Okay. This is located on the map. To me, this is the only map that's worth looking at. This is a light pollution map. This horrible white blob is Ottawa. And white means horrible, that's a technical term. Mike Wirtz Observatory is right here. And for reference, this is FLO right there, which means it's one whole color band apart. It means that Mike's observatory has 1/3 of the light pollution that the club's observatory does at Fred Lossing Observatory. So obviously I observed M13 and M31 and and the California Nebula and the Orion Nebula and the Horsehead Nebula and the famous Galaxy NGC 7331 and Pegasus, but everybody observes those things all the time. So instead I'd like to talk about 5 unusual objects I happened to observe last Saturday. And this first one is NGC 7332. By the way, trick is you take your favorite galaxy, take its catalog number and add 1. And you might discover something new and interesting. This is NGC 7332, which gets no good press at all. But it's a fascinating pair of galaxies. This is NGC 7331. They're both 60 million light years away. This galaxy here has a disk of gas in it that's rotating against the direction of the stars, and as a result has a peanut-shaped core, which you really can't quite see here. This galaxy here, which is gravitationally bound to 7332, although they're far enough apart to not interact, we just missed a supernova. It was in 1989, which, you know, on the terms of how often supernovas happen, it was just missing it like that. These are a very nice, interesting pair of galaxies to observe visually in Pegasus. And speaking of galaxies in Pegasus, next one please. This is a very pretty interacting pair which looks like a miniature version of the Whirlpool galaxy M51. It's quite a bit fainter. As like M51, there's a large spiral galaxy interacting with a small one near the end of the spiral arm, and the strong spiral structure here is being induced by the gravitational interaction of the satellite galaxy. Although this one is about 1/10 the diameter of M51 and is considerably fainter, this actually would probably be a good challenge object, although I'm not sure I'm allowed to say that this time.
No.
We were able to faintly distinguish a hint of spiral structure in this galaxy, but it was fascinating to look at and is not something I had ever seen before. Next, please. Along the lines of looking at galaxy companions, we decided, gee, it would be really cool to see the companions of the Andromeda Nebula. So everybody knows about the 2 main companions. This is M32, this is a galaxy all by itself, and M110. But there are actually at least 2 other companions that are quite interesting. Next, please. This one is the dwarf elliptical galaxy in Cassiopeia, which is about 7 degrees away from the Andromeda galaxy in angular size, but it's orbiting around the Andromeda galaxy. Most elliptical galaxies are extremely old stars. So this one's unusual that it has signs of relatively recent star formation. This is very remarkable. Visually, these things are difficult to see because they don't have an edge. They just kind of peter off to nothing. And it's, depending on the size of the aperture telescope you're using and the magnification, you get impressions of it having completely different sizes. You may only see this bit, or you may see that much, or you may see that much, or in deeper photograph you may see that much. I'm not sure that giant elliptical galaxies actually ever have an end to them. NGC 185 has a companion. It's another elliptical galaxy. Next one. Well, this one is spheroidal. These 2 are actually gravitationally interacting together as well as going around M31. This one is about magnitude 10.5. It's spread out over a considerable distance and is very difficult to see. It also has no edge. And the curious thing about this one, it's got no core. One of the distinguishing features about looking at a galaxy versus looking at a comet is galaxies always have star-like nuclei. And comets don't. They tend to have large nuclei. And this one looked just like a comet. So this is pretty cool and difficult to see. In fact, if I was allowed to say Deep Sky Observing Challenge, I might suggest that observing the 4 satellite galaxies of M31 might be a cool thing to do. But anyway, I'm not allowed to say that. So after
2 months, you can have any challenge you want.
Okay. So we said, gee, it'd be neat to look at a real comet for comparison. So we went and found next one, Comet Christensen 2006, which is in the constellation Cepheus. And this is pretty much what it looked like in my telescope. And the reason why this is fabulous for me, although this looks like a little smudge, is usually when you look at 10th magnitude galaxies, they're very far away from the Earth. They're not close enough to the sun to have much ice and water vapor being blasted out of them by sunlight. And if they do have a tail, it's straight behind the comet because the tail always points away from the sun. And from the comet's point of view, we're very close to the sun. But this one showed in the eyepiece a distinct asymmetrical coma and a tail going off into the eyepiece. The nice thing about this comet is it's going to stay magnitude 10 for the entirety of November, and because it's in Cepheus, it's going to stay circumpolar for an entire year, so we get to watch this thing for about a year. And it's a real comet. Next slide. I've saved the best for last. This slide represents the best part of the Star Party, and that best part is, before I went out, I sent an invitation out to the RASC member list and 2 other astronomy lists in Ottawa, and 8 cars full of astronomers came out to join me, and they're all sitting up in the darkness here. You see that? And this is the best part, because Bruce Harding took this photograph of Jupiter, the Moon, and Venus, and Pierre Montin set up his high-tech observing equipment. It's a launcher. He observed toroid meteors, and he saw a fair number of them last Saturday. Apparently, there was an outburst of them for about half an hour, which was maybe 3 or 4 times the nominal rate of the meteor rate. Ken Whitnall brought a very impressive astrophysics equatorial mount and refractor and set it up, and then set it up and set it up. And I'm not sure he did any observing last night, but apparently he discovered that if you use a compass to roughly pull around your telescope on a farm, you may be up by 7 degrees because the fences, of which he's set up 2 feet away from, are electrically powered. And Joe Silverman set up his telescope and observed open clusters, and I had a very enjoyable argument with him about him liking open clusters, thinking they're great, and me thinking that they suck, and of course we were both right. And a fellow from Kingston showed up, Ken Kingdon, who Ken is a great guy to observe with because you never have to bring a star atlas or an observing list with you because he's got them all in his head anyway, and he came with a list of 17 galaxies. So we picked one, and that was the one we saw. And the best part of this astronomical observation was running along like a bunch of 8-year-olds looking at the eyepieces saying, "Oh wow, this is great, you want to look." The word observation doesn't really quite capture the fun you can have doing this. It's not writing a report or publishing a scientific paper. It's looking at cool stuff with your friends. Astronomy, the most fun you can have in the dark with your clothes on.
Yeah, this is M15. It was the observing challenge. And I did this on September 18, 19, and October 18. And it's unusual for me because these are very short exposures, so that they're 60-second exposures, except unlike Paul, I took 250 of them and stacked them. So we're looking at almost 4 hours of exposure here. And the reason that I did this was so that I could find Pease 1, which is a planetary nebula in the middle of this thing. And it didn't show up. It was a lot of work. It took an 03 filtered image about an hour long, and it didn't show up in that. The reason is my telescope is too wide field for it. You need to really zoom in on this to see it. But it is there. Once I followed Attila's instructions and counted the stars over, it was that little blip there, but I certainly couldn't pick it out as being different than any of the rest of it. By the way, M15 is just about my favorite visual cluster, too. It's a fabulous target to look at, and if you get out, see it. Okay? And the other imaging challenge was from last month, and Attila had two challenges that I recall. The first one was the galaxy right here, which is IC 1296, and that shows up easy enough. And then the next one was to see the outer halo here, which shows up fine too. And I thought it'd be really neat to get the halo to show up, and then also have a really nice picture of M57, which is the ring nebula, which is red and blue, turquoise maybe. And as soon as I stretched it to see the halo, the colors vanished. And I screwed around with it for about an hour, and then I quit. Anyway, that's my image there. Again, a little bit too wide angle for that, but that was a 3.5 hour exposure. And the galaxy and the halo showed up fine. Anyway, thank you.
Excellent. Thanks. All right, well, this is my first stuff back since a year ago, I guess. Just because recently, well, things have just sort of fallen into place for this. Made a little money in the summer, so I spent it all on cool stuff. I got a laptop now so that I can actually use my webcam, and I got a telescope donated to me. So this was what I did. I think the second thing I did with it. I thought I'd give Jupiter a try. And well, that's sort of how it turned out there. You can sort of see the bands there. That's good for me. And then I took some lunar images with it through this 4-inch reflector, and I decided to try and give doing a mosaic a try. And so it's not perfect, but
I'm just going to turn the light up just for a second. You okay?
yeah, sure.
There you go.
Yeah, it's certainly not perfect, but it's I think it's pretty good for a first try. I especially like the crater there that's visible just beyond the Terminator. These were all, individual images, and I flipped them around too. And then this was with the DSLR I got. And it got about the same magnification as the webcam did. The webcam zooms in because of the tiny field of view, but the DSLR, I zoom in because I have to use a Barlow to get it to focus right. So I was using a Barlow with afocal projection on these, and I thought I'd give stitching them together a try too. And so I focused on the Terminator area and just took a couple images around to put it together. And the tracking's not perfect, so as you get in closer, you'll notice it's a bit off. But the main difference between these and the webcam is when you put them on my desktop, I put the webcam ones on, they fill a nice little box in the center. But then I put one of these on and it fills the screen with perfect resolution. So that's the 12 megapixel Rebel XSI. Thanks. Yeah, these are the close-ups of the images I used to stitch. This one I especially like. There's something I couldn't quite figure out. It doesn't seem to show up very well here, but around this area there was a sort of fuzzy white thing. I can't figure out what kind of a smudge it was, but it was a smudge indeed. I thought it looks kind of cool, like some sort of ejection from the surface. But I think this one was my favorite of the DSLR ones. Just the stuff around the edges here too, especially. You see, the way you can see just the sort of craters.
Yeah, a lot of nice
over
detail
the
there
edge.
for sure.
Yeah.
Right. I think we got another one there. Chris and I did this for you, right? Just to show you can see on. Could I borrow the pointer just for 1 second, Peter? I mean, you can see the way you stitch things together. You can see the lines there going across, and you can see some of them coming across here. We just put a bit of a photo mosaic of his mosaic together for him. And I think that's going to be the last shot there, right? Tim, could we have the lights up, please? Now this was a response to last month's lunar challenge, was to produce a mosaic of the moon, either by a sketch or by photograph, all right? And I said there would be a special prize, and indeed, we have this little prize. We have a moon map, so you'll be able to identify what those little smudgy things are. I like that technical talk. This moon map is courtesy of Tim Cole. Maybe if you can take one side of that. All right, one out here. All right. So, if next time when you're getting ready to stitch everything together, there's your guide to do it. When you become really famous and really rich, when you've made a lot of money, and you can travel out a bit farther out into space, you can then start doing a mosaic of the far side of the moon. All right. So well done, Peter. Very good. Very good. Congratulations. All right. I'll let you take that fold out. And here's your observing token. Thanks very much, sir. All right. Well done. Well done. All right. Where's?
Okay. I hope there's other slides. Oh, okay. Here we go. Right. So the I thought there was a title on that. Oh well. No. Go back.
No, that's it.
I changed all my slides. Okay. So this is the challenge, and the challenge basically is to see this at all. and the object is NGC 253 and NGC 288. So now you can advance. So there they are. So to find this, so this is pretty much the view that you would see naked eye looking to the south. The problem with seeing this at all is that it's very low in the south. So that means it never gets very high above the horizon, and you're challenged by seeing it through the inevitable light pollution and haze and everything that's around the southern horizon. And if you could just go back and forth between those two, you can see them when the circles go away. You should still be able to see those objects. Okay, so let's go back again. So the thing with, so there's NGC 253, and that is actually theoretically possible to see in a naked eye. It's about 7th magnitude. Now, the reports that I've read about this being seen naked eye are from Australia and Hawaii. So the object is obviously much higher in the sky then, but if the sky were extremely dark, you might be able to even see that naked eye. Just advance again, Chris. So there is one other thing here, which is invisible even in the Hubble Space Telescope. And we didn't have a trivia question this month, as I recall, so this will be the trivia question. And everybody except Glenn LeDrew is eligible to answer this. So it's just about here. Glenn can tell me if I'm close to it. Is that about where it is, Glenn?
I know what it is.
Okay. Gary knows what it is, but
I'm excluded.
okay, so anybody who doesn't know can guess what it is. Okay, so if nobody can guess, I guess we'll have Gary give it. So any guesses as to what that is?
Looks like a G.
Looks like a G, the letter G.
Okay, so go back one, Chris. So like I say, it's actually not visible at all. But it's right there.
You got the wrong initials on it, okay?
The wrong what?
Initials, you got N instead of S. P, right?
Yeah, I know, but it's in it.
Okay.
Okay, so nobody knows what this is. So Gary, you'd better tell us before we get. Okay, so this is the South Galactic Pole. So what that means is that's about as far away from the Milky Way galaxy as you can get in a southerly direction. So that means that any galaxies that are in that area are going to be the least obstructed by any obscuring gas or dust from our own Milky Way galaxy. But basically, these two objects are extremely bright, and it's a wonder almost that they are not Messier objects. So let's go forward again, Chris, and to the next slide. Actually, I should go back, because I forgot to mention how easy it is to find. Beta Cetus is one of the brightest. There's very few bright stars in that direction because it is looking away from the Milky Way. The bright star Fomalhaut is over here, Beta Cetus, and to find it's very easy, a triangle here and a triangle here, and then NGC 253 and 288. So next slide is, this is what you might see in binoculars, and you should be able to see these two objects in binoculars, NGC 253 and 288. 288 is a globular cluster, and so again, Chris, you've moved the triangle. That triangle is no longer lined up with the star. Something must have happened there. Okay, but so basically the triangle is these stars here. Is it visible in that shot? Oh, well, I don't have a picture of it, so. Okay. 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 Okay, so down here somewhere? Yeah. Okay, so certainly in a binoculars you should be able to see these two objects. Next slide. Okay, so this is a picture I took last week of the entire galaxy. So it's actually quite a spectacular galaxy if you can put a telescope on it, and it's huge, quite large. And there's one other thing here. So that this is not a challenge to see this in a telescope, because you know, it'll look pretty good, assuming the sky is decent. But what is down there, Chris? If we could advance one, and that is another very small galaxy here, which Attila was kind enough to actually identify, and it's about 15th or 16th magnitude. So that would be a challenge to see, I think, in even a large telescope. But it, you know, photographically, of course, it shows up. Okay, and I think there's one other shot. Oh yeah, so this is the NGC 288. Not a very long exposure, and I was kind of short of time. I just did that earlier this week. So just 17 minutes. Probably, you know, it's nowhere near as spectacular as some of the other globular clusters. It's a lot sparser, and being low, you won't see too much.
It's almost like M11 in that picture.
It does, yeah.
Almost like M11, but except M11 has M11 is kind of square, but it has a very bright star in it. Yeah, it almost verges on being an open cluster, doesn't it?
Yeah. It looks like similar to M71, the type of looseness to it.
And just as a matter of interest, both these two pictures that I just took recently, there was no guiding in them. I just did polar alignment, and then I decided to see how well it would track without any guiding, so it wasn't too bad. They were 5-minute exposures. And I guess that's it for the challenge objects, but there was one other thing here.
Yeah, okay.
And that was, last month, early in October, was a good chance there were a number of good passes of ISS. So this was one that I got, well, like it says, October 6th. And I guess that's it.
So Ralph, how did you follow the ISS to get that shot?
Well, this was basically just, the observatory slit is only about 2 feet wide, so I only had about 20 seconds to track it, but it's tracked with the finder scope.
Okay.
So just like an 8-power finder scope tracking on it. So that's not the whole story, because obviously that's centered within like a second of arc or something like that. No. As you take pictures of this, probably it'll get captured in about 1 out of every 10 frames, and so 9 out of 10 frames won't show it at all. And then most of them, you know, it'll be like the frame will be something like this, and it'll just be off in one corner. And so no, you have to reassemble it with it centered in each one. So you can't. No, you can't possibly track it like with this kind of accuracy. You have to reassemble it and recenter all the frames before you put them together like that.
Glenn.
Yeah, it reminds me of that kind of image processing done of the infamous Zapruder film, the 8mm film of President Kennedy's assassination, because the camera was shaking when they did the enhancement to get it exactly centered. It's very much like that, where you have image motion. You see the blurring of the frames, but it just was recentered in that similar fashion.
Yeah. Of course, some of the frames are blurred because the telescope was blurred just from moving the telescope, but that's what it is.
Well done, thank you. So this is the end of the program for this evening. Yeah, we're 10:30. Oh boy. All right. So just a reminder, we have calendars on sale on the back. Also, if anybody's looking for Sylvie to return a telescope, Sylvie is right in the middle with her arm up. Okay. Also, please, if you're interested in attending the dinner, and I really, if you've never done something like this, I encourage you to come on out. It's a wonderful evening, and Paul has the tickets right there. All right. Okay. So here we go. Any contact information, you can always find information on the website as well to get into the center. And attendance tonight was?
Apparently it was 138.
130. Yeah, I think it was 137 was what Gary counted tonight. So the observatory is closed this evening because we have an overcast sky. And Estelle, were you opening the library still? Okay, so Estelle's at the back. She can open the book library just on the other side of the bulkhead here. We have coffee and pop and snacks out in the lobby, courtesy of Anne and Art Fraser. So thank you very much for doing that. They do a wonderful job with that. So, All right. So next month, our meeting's on. That's right. A couple of things here actually. Our dinner meeting, next week, but also on December 6th. Okay. We have our next RASC meeting is on December 5th. That's the first Friday of the month. The very next night, of course, is the museums event with Dr. Jamie Matthews. The guy is an intense, sparkling speaker. It's going to cost you $5 or $6 to attend this thing, and he's a wonderful speaker. Friday, December 5th, that'll be my last meeting as meeting chair, and presumably, unless somebody else is getting their name in on the nomination slate, we're fully expecting Attila Danko will be taking over as meeting chair. For the last meeting there, there's a bit of an annual general meeting. It should only take about 15-20 minutes because we don't have too much on the nomination slate other than everybody's going to be acclaimed, I think. But we've got a couple of special things coming up. Simon Hanmer's going to be here with a special simulation that he's put together. Okay, it's the first of a 4-part series, so I'm be handing something off to Attila to carry on over the next number of months. You don't want to miss this. I've seen it. It's fantastic. Yes, thank you. I was going to say that. Yes, the December meeting is our swap table, our pre-Christmas swap table. If you have items that you would like to sell, we'll have tables set up here starting shortly after 7 o'clock, and you can bring your wares to sell here. I'm hoping that Kent will be here from Focus Scientific. We've already had clearance from councils for a vendor's table as well, so I'm expecting him. What else? We've got a couple of fun things lined up for something that Chris and I have been working on for that December meeting as well, and if I can get things organized, it should be something really a lot of fun. All right, so let's go and have coffee and that, and we'll see you next month.